topic is use of Python in medical imaging, and I've spoken about co-founder of the group and a bit of all that. The disclaimer that I mentioned, medical person or a medical doctor, but I've worked closely with them and they get to share a lot of what would happen and all that. That has led to me being able to think and then process of creating visual of intervention. Medical imaging is used for both diagnosis and therapeutic purposes as such effectively care for patients. Common magnetic resonance image. I think that's a bit clear, so I probably don't need to expatiate on that. So like I was saying earlier, would I say opportunity are blessed not to have this like an MRI machine, and that's how it looks. So I will talk briefly about its evolution. Remember 1895 with that guy with a very funny name by his discovery of X-ray, and then made an entrance into the world of medical imaging in 1970. That's when CTs and MRIs came up. And thereafter, DICOM, that's Digital Image and Communications in Medicine standard, was formalized to solve the problem of compatible machines. So prior used to do scans and all that, and they were generating their own images in various formats that were not interoperable. So the standard for DICOM was created that regardless of whatever machine was used to do the scan, it says first generation of PACS, which I'll talk about in the next couple of slides, came up in the early 90s and was designed to deliver relatively large files over radiology department networks. So what is DICOM in DICOM, which is digital imaging in medicine? So this is a standard for handling, storing, printing, and transferring information. That's definition and network communications protocol, and the files are saved in .dcm extensions. It's not just about images alone. A typical DICOM file contains a whole and then it allows for transmission and electronic reports via network. It enhances the productivity of the modality, the MRI modality, the CT modality, but at the center of it all is a server that we call the PACS. However it is that you design to scale or design your stuff. So when the scan is done from any of the machines, either the MRI or the CT, the image is uploaded to the central system, which is the PACS server, such that any medical person or doctor can be at the client's system and view whatever image that was scanned from any machine and do what they call their reporting for other people or other medical people to use. So now to the real thing, which is Python and how it comes into play. So there is a PyDICOM is a library that we're going to talk about, and it's a pure Python package for working with DICOM files such as medical images, reports, and radiotherapy objects. It makes it easy to read complex files into Pythonic structures for easy manipulations. Modified data sets can be rewritten again in DICOM files. It is not so, let me just explain those two few points. So PyDICOM can actually pick up DICOM files, read through them, read the data that I said were embedded earlier, and it can actually do a modification of such data, and then you can resave it back as another DICOM file. It can do that. And then the last point says it is not a DICOM server. There's another concept of a DICOM server, and it is not primarily about viewing images, although, you know, like I said in the earlier point, that it could be used to modify image. What's the point when you can modify image and you can't preview what you've done? So it can also view. It can also, but it's not primarily for viewing, but it's really more about manipulating the data set that is inside the PyDICOM or inside the DICOM file. So a simple usage that you see if you go to the home page of that library, that the PyDICOM library, is this example, which reads a radiotherapy file, changes the patient's position from head first supine to head first prone, and save the new file. So that's the supine position. So you could just revert and then have the other prone position through the use of PyDICOM, and you can save it as another file type. So there'll be I'll show you a code example of how that works in a bit, but let me just quickly skip ahead to the next slide. So the code is on that repository, and which will be made available. So then to the other example, which is viewing images. So as mentioned earlier, it's actually really not majorly designed to view images, but it could also view images through these following options. So for instance, it's either you're using external libraries that are built for that purpose. So if you are a bit familiar about that space, you would have heard of Clear Canvas and a couple of other tools that are designed specifically for viewing. They have some complex tools that allow you to do some modifications. So I will bring up that. So these are like a list. Okay, it's not showing that. I'll bring that up later. Then that leads to the second code example, which I would also show in a bit. And there's really a whole lot more that we can do with PyDICOM, and there are several examples of such in this link, which I will still show to us. So then there are the DICOM web, and that's just a standard web-based medical imaging, and it's a set of RESTful services that enable web developers to unlock the power of healthcare images using standard industry tool sets. So much could be done. Reviews and reporting about medical images such as CTs, MRI scans, and other images can be a frustrating task, especially when you have to do it when you're viewing films under bright light. I don't know how many of you have been to the hospital and then your doctor or someone is having to look at something under some light, and then it's not that easy and all that. So, but gladly, most hospitals have moved, and diagnosis centers, they moved to PACS systems. So this is still a bit limited because radiology consultants have to physically go to those centers to write reports, because really, when you're looking at that image, how much sense can you make of it? It's only those that are trained to look at those images and make much sense of it that actually do what they call reporting, that can actually take to another doctor in another discipline to actually give you care. So those radiology consultants really have to go to several reporting centers or several diagnostic centers to do reporting and write image reports, because those systems are intranet-based often. So one solution pretty much would have been to move the PACS server up in the cloud, but you know what that entails for ubiquitous access, such that the consultants don't have to go from hospital to hospital or from diagnostic center to diagnostic center. But that's a bit costly because, you know, image files are large. By the time you store a couple of images, you are consuming so much cloud space and all that. So that's it. And then also internet access, internet connectivity. Good internet in Nigeria is not cheap. So you're going to incur a lot of cost handling images on the cloud and stuff like that. And also privacy issues. Companies, in hospitals like UCH and a couple of others who have issues with keeping their data up in the cloud and stuff like that. So in trying to innovate around that space, PyDICOM comes to help, such that we can build simple apps that help us manage this problem and build applications that are ubiquitous and are more cost effective. And this probably would be a simple project to start with, like a simple web application that would allow people upload their DCM formats or DCM files to the application, that's the web application in question, and allow experts to view, examine, and generate medical reports on such image, and have that report emailed back to imagine how it would be if you could sit down at the comfort of your home, upload your image to a web application. Someone at the end views the image and sends a report back to you that makes meaning that I can actually take to any other hospital and have it used. Wouldn't that be useful to people? So that is what I would show in it. So I've actually started working on a web app in that line, but I've not been able to finish. Okay, I'm trying to bring up the. So these are a couple of